Hello everyone, welcome back to our channel. Let's discuss the next topic, that is mass spectrometry instrumentation. We all know that the general principle of mass spectrometry. Initially we are going to take the sample. The sample must be in the vapor phase, that is subjected to ionization phenomena. We will come up with molecular ion. The molecular ion subjected to fragmentation, thereby we will get the fragment ions. The fragment ions are separated in the mass analyzer, thereby we can detect the different kinds of the positively charged ions based on their m by z values. So how can we get the m by z value? That can be discussed by using the topic called as instrumentation. Okay, let's see the first one. Here we are having sample reservoir. It means that what we need to load the sample in this particular reservoir. The sample must be in the what? Vapor phase. We are having three types of samples. The samples may be solids, liquids or gaseous. We must convert all the samples into the corresponding vapor state. Right? Here see this one. All the sample molecules are entered into what? Ionization chamber or not? In the ionization chamber, what we are having? We are having a filament. Right? Here what is happening? The transfer of electrons takes place between the filaments. From the top, the electrons are coming. From the left side, we are sending the molecules. So what will happen? All the molecules are bombarded with what? Electron beam or not? So once the molecules are bombarded with the electron beam, what is happening? The ionization phenomena takes place. Removal of a single electron from each molecule will take place. Thereby we will come up with what? Different molecular ions. All the molecular ions are subjected to what? Fragmentation phenomena. Thereby we will come up with simple cations, radical cations, radicals and negatively charged species. All these species are entered into what? The mass analyzer from the ionization chamber. Once all these are entered into the ionization chamber, what we are doing? We are removing the radicals and negatively charged ions. Why? Because the mass instrument cannot recognize these type of ions. Mass instrument can recognize only positively charged ions and radical cations. That's why these two ions are continue to send further, but these can be removed by using an vacuum pump. Okay, so in the ionization we are having different types of procedures commonly called as ionization methods. This particular procedure is commonly called as electron impact ionization. Simply what we are doing, gaseous samples are coming, simply we are bombarding with what? Electron beam. This is the old technique, electron impact ionization. This is the first method. The second method is what? Chemical ionization. So how can we do the ionization phenomena? For that purpose we are having second method called as what? Chemical ion. In the chemical ionization, what we are observing? Ion molecule interactions. In generally what happens in chemical ionization, we are taking some molecules. These molecules are commonly called as reagents. Okay, these can interact with your sample molecules to generate the ions. How the phenomena takes place? Let us see. So initially we are taking methane, right? It is commonly called as a reagent. So the methane is initially subjected to the electron bombardment. Thereby what happens? We will generate a molecular ion of the methane, right? After that what is happening? This molecular ion is interact with neutral molecules. Already we know that if we are sending 10 molecules to the electron bombardment, what happens initially? The 10 molecules will not converted into the molecular ions. So 6 to 7 molecules are converted into the molecular ions, and remaining are neutral in nature only. That's why what happens initially? What is happening? The formed molecular ion combined with the neutral molecules, thereby produces what? CH5 plus ions, positively charged ions. Remember, this is one ion produced. In the latter stage, what happens? It is the molecular ion. Here we are having what? CH bond or not? That is subjected to hemiheterolysis. Because of the hemiheterolysis, what happens? CH3 plus H radical. So here we are getting one more positively charged ion. The formed positively charged ion is combining with what? Neutral molecule to produce C2H5 plus. It means that what? In chemical ionization, whatever the reagent we are using, that reagent is initially involved in the electron impact ionization to create the positively charged ions. Okay, from the reagent we have generated what? Positively charged ions. These ions will interact with your unknown sample molecule, CH5 plus and C2H5 plus. These will interact with the unknown sample ions and they can produce what? M plus H peak means M plus 1 peak, M plus C2H5 peak. C2H5 means 29. So whatever the molecular weight we are having, to that molecular weight we need to add 29. That peak can also appear in the spectra. In this way, the chemical ionization technique takes place. Okay. Next one, desorption techniques. In case of the solid and liquid samples, generally we are using that. Desorption means what? Removal of the substance from the surface of the material, right? Where the material is adsorbed. That technique is commonly called as what? Desorption technique. The first one is what? Field desorption. In the field desorption, what we are doing? We are taking an emitter rod. At the surface area, what we are doing? We are placing our compound. Our compound is pasted at the surface area of the emitter. See this one. Now what we are doing? We are supplying high electric field. High electric field we are supplying. Because of the supplying high electric field, what is happening? The molecules are generating the ions. This kind of phenomena is commonly called as what? Field desorption technique. Generally, this technique is used for the polymers and biologically active molecules. It means that what? For higher molecular weight compounds, if you want to study the mass spectra, what should we use? We need to use field desorption technique. Okay. What is the next type of technique? Fast atom bombardment technique. This is also very simple. The name itself indicates fast atom bombardment. A beam of atoms we are sending. Which atoms? Xenon atoms. Already we know that noble gas elements are highly unreactive in nature. They cannot react with the other elements. That's why what we are doing? We are sending a high energy beam of xenon atoms in a fast way. That is commonly called as what? Fast atom bombardment. So in the fast atom bombardment, we are sending fast atom beam. That beam is what? Xenon atoms with energy 6 kilo electron volts of energy. Very high amount of energy we are sending. Where we are sending? Let us see. We are having unknown sample. The unknown sample is going to mix it with a liquid matrix. It means that what? We are mixing two things. One is the sample and another one is the one liquid mixture. Because of the interaction of these two, we are preparing a paste. That is commonly called as analyte. What is the name? Analyte. So, to the analyte we are sending what? Fast atom beam. Then what happens? We will get the molecular ion. See this one? Here we have taken a probe. At the surface of the probe, whatever the analyte we have prepared by the combination of the sample and the liquid matrix, what happens? That is pasted here. Then we have supplied what? Fast atom beam from the beam source. Then we are getting what? Molecular ions. This is commonly called as fast atom bombardment. You need to remember one thing. What are the materials which we are using as a liquid matrix? Glycerol, thioglycerol, M-nitrobenzyl alcohol, diethanolamine, 2-nitrophenyl octyl ether, sulfuric acid, dioctyl phthalate. These are the species or these are the molecules which are used as a liquid matrix to mix with the sample to prepare what? Analyte. So this is about the what? Fast atom bombardment technique. So we are having solids, liquids and gases. For that purpose we are having different kinds of the ionization techniques. What are those? electron impact, chemical ionization, field desorption, and fast atom bombardment. So by using these techniques, we are creating what? Molecular ions. Further subjected to fragmentation, we will get the fragment ions. Okay. So if you see the instrumentation of the particular mass spectrometry, we can have three lines. What is the first one? Creation of ions, separation of ions, generation of ions. Just remember three lines. Creation of ions, separation of ions, and generation of ions. Creation of ions means what? By using all the ionization techniques, what we are creating? Molecular ions or not? The molecular ions are subjected to cleavages. What we are creating? Fragment ions or not? So this is the creation of ions. Now separation of ions. Once the created ions, fragment ions, are entered into the mass analyzer, what is happening? They are going to be separated depending upon their velocity and the mass. So see this one, M1, M2 plus radicals are directly coming. So these are commonly called as what? Positively charged species or positively charged ions. See this one, how they are separating. The magnetic field is separating these ions. That is commonly called as what? Separation of ions. Now next one is the what? Generation of ions. Whatever the ions which we have separated here, what is happening? They are going to exit through the slit. Then who is going to be collected? The collector will be collected each ion one by one by one, one by one, one by one, one by one. Later they can give the information to the recorder in the form of what? Generation of ions. Finally, from the starting to end, which ions are generated? That is commonly called as what? Generation of ions. Okay, so till now we have discussed what? Sample and the things happen in the ionization chamber. Now let's enter into the mass analyzer. What we are saying? Depending upon the M by Z ratio of each and every positively charged ions, the mass analyzer separate these ions. That's what we are discussing, right? So how can we calculate the M by Z value of the positively charged ions? For that purpose, we are using a concept. See this one. This is the mass analyzer. In the mass analyzer, what is happening? The ions are separating in this way or not? So in a path, the ions are taking this pathway. In this pathway, see this one. The ions are throwing in this manner. Right? So we need to observe the M by Z value of these separated ions. How can we generate? See this one. If the ions are taking this particular pathway, we can create what? A circle or not? The circle is going to have R value. The R is what? Radius of the curvature of the path according to mathematics. So initially the ions are in the flowing state or not? They are continuously moving from one position to another position. Because of that reason, ions are having the what? Kinetic energy or not? So the kinetic energy of accelerated ion, we know that the formula of the kinetic energy of mv square, that is equal to charge into potential applied. So whatever the ion which we are having here, those ions, kinetic energy is going to equal to the charge into potential. M is the mass of the ion, V is the velocity of the ion. See this one, in presence of the magnetic field, the charged particles take the curved pathway. The charged particles are taking the curved pathway. Because of the curved pathway, we are going to observe what? Radius of the curvature of the path. That value is equal to R equal to M into V by Z into B. B is the strength of the magnetic field. R is the radiature of the curvature path. Right? So this is the equation 1 and this is the equation 2. So from the equation 2, what we are calculating? V square. We know that the V value, V equal to what? R into Z into B by M. So square 2 times. So R square into Z square into B square by M square. Substitute this V square value in the equation 1. See this one, we have V square or not. So the V square value is substituted in the equation 1. Thereby what is happening? Half into M into this particular V square value equal to Z into V. Here Z square is there, so one Z is going to be eliminated. Here we have M and here we have M square, so one M will be eliminated. So from that what we are getting, half into R square into Z into B square by M equal to potential. From this what we are getting, M by Z, the M by Z value equal to B square into R square by 2 into V. So by using this particular formula, we are going to calculate M by Z value of each and every simple cation or the radical cation. See this one, M1 plus M2 plus radical. This is the simple cation, this is the radical cation. So simple cations and radical cations, M by Z values will be calculated by using the formula M by Z equal to B square into R square by 2 into V. B is the strength of the external magnetic field, R is the radius of the curvature of the path, and V is the what? Potential difference or applied potential, we can say. So this is about the what? The instrumentation of your mass spectrometry. In this way we can recognize all kinds of positively charged ions by using the mass spectrometry. Okay, so in the next video or the last video, we will be having some of the real examples fragmentation discussion.